Here is the last video for the Chapter 5 study guide for Algebra 2 Honors today. So we are starting off with number 18. Number 18 says to solve for x, we have log base 6 of x plus 3 plus log base 6 of x plus 4 equals 1. Now, how do we approach this? That's always kind of the hardest part here. And so the one thing I would do is I would first see, okay, well, we have the same base, and on this side there's only just a number, no log, no nothing. So what I would do first is I would combine these. I want to get, no matter what, I want to have one single log on the equal sign. So because we're adding and they have the same base, I can combine them by multiplying. So it would be log base 6 of x plus 3 times x plus 4 equals 1. Now I can either simplify it now or simplify it later. Whatever you want to do is totally fine. But at this point, what you should recognize, and what I mean by simplifying is just multiplying those together. But what you should recognize is there's not a log on this side. So I can't just get rid of the log. So what I need to do is I need to change it to exponential. Now, when I'm changing it to exponential, let me reiterate this. You are not changing the equation. You're just changing the way it's written. So this, in logarithmic form, is the same as writing it as 6 to the first power equals x plus 3 times x plus 4. So going from logarithmic to exponential, it's just a different way of writing it. It's the same exact problem, it's just a different way of writing the same thing. Okay, so 6 to the first power is just 6, and I am going to multiply my x plus 3 and my x plus 4 together. So that would be x squared plus 7x plus 12. Now, at this point, I'm hoping that you guys are like seeing that x squared and you're thinking, that means to be able to solve for x, I have two choices. I can factor or I can use the quadratic formula. But either thing, like either method that you're going to use, you have to get everything over to one side, so this is equal to 0. So I'm going to subtract 6 from both sides of the equation, and so I have 0 equals x squared plus 7x, and then 12 minus 6 is 6. Okay, so now at this point, I would either use a quadratic formula or factoring. I'm going to factor because I can. If I couldn't, I would use the quadratic formula. So x plus 6 and x plus 1 equals 0. Now that it's factored out and it's equal to 0, I can set each factor equal to 0. X plus 6 equals 0, and x plus 1 equals 0. Okay, so now that we are dealing with logarithmic equations, we need to check our answers. So I need to plug it back in up here because my variable is within the log. It's one of the numbers within the log. It's the argument. We have to check our answers. So negative 6 plus 3, well, that's going to get me a negative answer. Negative 6 plus 4, that's going to get me a negative answer too. So negative 6 is not a valid option here. With negative 1, well, negative 1 plus 3 is 2, and negative 1 plus 4 is 3. So that's the only one that works. So my answer is x is equal to negative 1. So if you don't check your answers, you're not going to get, you might get it wrong. So you need to make sure you double check your answers every single time. Okay, so for 19, we have log of 7x minus 12 equals 2 log of x. Now, remember, when there is no log, when there is no base, it's a base of 10. So these have the same base. It's the same log base on both sides of the equation. Now, the first thing, before I even get to going over that, the first thing I would do is move this guy up. I would move it to a power. So it would be log base 7x minus 12 equals log of x squared. So at this point, when I have the same base and a log on both sides, I can ignore the logs completely and just focus on what's inside. So that's 7x minus 12 and that x squared. So I would be able to set them equal to each other. 7x minus 12 equals x squared. Now, again, just like we did in 18, you have an x squared. That should be your flag in your brain that you need to get everything to one side of the equation. So I'm going to move everything over here. You could move everything over here. I just don't like to deal with a negative x squared. I would prefer to keep my x squared positive. So I'd subtract 7x, and then I would add 12. And now I would either factor or use the quadratic formula. I can factor this one, so I'm going to factor. So it would be x minus 3 times x minus 4 equals 0. Now that they're multiplying and it's equal to 0, I can set my factors equal to 0. And so I get x is equal to 3, x is equal to 4. Now we can check our work again. We can plug it in. So 7 times 3 is 21 minus 12. That's positive. Good. Log of 3, that's positive. 4, so 7 times 4 is 28 minus 12. That's positive. And then log of 4, positive. So both of my answers work. So x is equal to 3 and 4. Okay, so let's continue on. Let's start on number 20. Almost there. So for number 20, it's very similar to number 18. The only thing that's different is the base here. My base is, because it's ln, that means I have log base e. So the first thing I'm going to do, I notice that they are subtracting. So if they're subtracting and they have the same base, we combine them by division. So it would be ln of x minus 8 all over 2x plus 1. Oops. Okay, so now that we've combined them, at this point, I have a log on this side and I have a single number on this side. So the only way I can start to solve this is by rewriting it in its exponential form. So it would be e to the first power equals x minus 8 all over 2x plus 1. Now, remember, you're not changing the actual equation. Nothing is changing. You're just rewriting it in a different form. Okay, so at this point, what I am going to do is we need to solve for x, right? So that's our end goal. And so to start us off, I'm going to multiply both sides by the denominator, 2x plus 1. I'm going to continue. Actually, I'll do some of my work right here. Okay, so we have 2x plus 1 times e equals x minus 8, right? Because our denominator is now canceled out. Now, at this point, I would prefer, again, if you guys kept it with your, e there, and then you rounded it at the end. If you didn't, at this point, I wouldn't mark you down, but I would prefer you guys to not round until the end. So we're going to distribute our e. Remember, it goes to both 2x and to 1. And so it would be e to x plus e equals x minus 8. So again, we're solving for x, so we want to get all of our x terms to one side of the equation. So I'm going to subtract x from here to both sides. So it would be e to x minus x plus e equals negative 8. This e right here, it does not have an x with it, so I'm going to move it to the other side. So e to x minus x equals negative 8 minus e. So I subtracted e from both sides. So now on my left side of the equation, I have both of my x terms, which means I have a GCF. Both terms have x, So I can factor out the x. So e2 minus 1 equals negative 8 minus e. And so now to get x by itself, all we have to do is divide. Now if it makes more sense to write it as 2e minus 1 divided by 2e minus 1, by all means do that. Okay, so x is equal to negative 8 minus e all over 2e minus 1. So into our calculator, we need to plug that in. So we would put negative 8 minus e, and then I would just get that and divide by 2e minus 1. Now again, make sure you put the parentheses around your whole denominator to make sure you get, it's dividing by the whole denominator. If you didn't put parentheses, it would just be dividing it by the 2e. So at this point, we get our negative 2.42. So x is equal to negative 2.42. Okay, so we need to plug it back into our expressions and check to make sure it works. So negative 2.42 minus 8, well, that's a negative minus a number is going to get me a negative answer. So right off the bat, I know that this isn't going to work. And so I actually have no solution here. So remember to check your work. It's super important that you guys check your work and make sure that once you plug it back in, the value is a positive number. Okay, so the last problem on this one that we have is number 21. And so 21, it looks pretty big, but it actually ends up to work out kind of nice. So what I notice here, and whenever I have two logs, like two different logs on each side of the equal sign, my first thought is I gotta combine them. So I have a minus, and they have the same base. Same thing over here, minus, same base. So I'm gonna combine it on both sides separately by division. So it would be log base A of x minus 7 over x minus 2 equals log base A of x minus 4 over x plus 12. Okay, so at this point, I have a log on each side of the equation. They have the same base, so yay, I can ignore that completely and just look at what's inside the log. So I have x minus 7 over x minus 2 equals x minus 4 over x plus 12. So first thing I'm going to do is I'm going to cross multiply. I'm solving for x. I don't like to have denominators, so I'm cross multiplying. So that means we have x minus 7 times x plus 12 equals x minus 4 times x minus 2. And I'm going to continue my work up here. So x minus 7 times x plus 12 gets me x squared plus 5x minus 7 times 12, which I'm blanking. Yep, I was right, 84. Okay, and then x squared minus 6x plus 8. Okay, so now that I have this on, I've solved it, I got rid of the denominators. At this point, what I would start to do is I would start to move everything to one side because I see that x squared. So I'm going to subtract x squared from both sides of the equation. But hopefully what you notice is the x squareds cancel. X squared minus x squared is 0. X squared minus x squared is 0. So we are left with 5x minus 84 equals negative 6x plus 8. So at this point now we are left with just a linear equation. And so we can just start solving for x. Add 6x to both sides. 11x minus 84 equals 8. Add 84 to both sides. And we get 11x equals 92. Divide both sides by 11, and I get x is equal to 92 over 11. Now, if you, which we do, we want to plug it back in. To make it easier on yourself, what I would do is I would do 92 on my calculator divided by 11, which is 8.36. And so 8.36 minus 7, that's positive. 8.36 minus 2, that's positive. 8.36 minus 4, positive. And 8.36 plus 12, positive. So you can either write it as 92 over 11 or 8.36. That's fine. Okay, so that's your answer, and that wraps up the study guide for Chapter 5. If you guys have any more questions, remember I will be after school on both Monday and Tuesday, and then I will, you can always contact me through Remind. So hopefully this helped, and have a good rest of your weekend. Bye, guys.